Welcome back. We are in number 14 of SPM Trial Paper, State of Perak 2012. Number 14, given sine theta is equal to W, for which theta is an obtuse angle expressed in terms of W cosecant theta. That's question A. Okay, take a look at that. Theta is an obtuse angle. What does it mean? Theta is between 180 degree and 90 degree. Alright, if you draw a diagram, if you draw a Cartesian plane, then it looks like this roughly. So the line is here. If this is a unit length, then this is theta. Okay, question A, cosecant theta. What is definition of cosecant? Cosecant is equal to 1 over sine. So cosecant theta is equal to 1 over sine theta. So that is equal to, but sine theta is equal to W. So cosecant theta is equal to 1 over W. That's the answer. B, sine 2 theta. Alright, sine 2 theta is equal to 2 sine theta cos theta. This is the formula that we all have to memorize, or at least you know where to find it in the formula list. Let's take a look at sine theta is W, but what about cos theta? Take a look at this here. All right. How do we define cos theta from sin theta? If we draw a diagram, a triangle, right angle triangle, with with hypotenuse of unit 1, and if this is theta, then this side over here, what we call that, the opposite side is W, while the adjacent is going to be square root of 1 minus W square. Then cos theta is going to be square root of 1 minus W square over 1. So let's just don't write over 1 there. But since theta is an obtuse angle, so it falls into the second quadrant. In the second quadrant, cos is a negative value. So cos theta is less than 0. So cos theta in this sense for an obtuse angle is equal to minus square root 1 minus W squared. So sin 2 theta is going to be equal to 2W and then minus 1 minus square root of 1 minus W squared. So that is going to be equal to minus 2W and square root of 1 minus W squared. That is the answer. But if you have downloaded my the trial paper of Perak SPM Trial Paper 2012, you probably have seen the marking schema. The marking schema probably will not show you the negative value. Let me show you the schema here. Let's take a look at this one. Like this is what the schema gives you: 2W 1 minus W squared, and this is clearly wrong. It should be a negative value then. Alright. Why? Because theta is in the second quadrant of the Cartesian plane, so cos theta should be a negative value. There you have it. So that's the answer. Let's move on to the next question. Number 15. Solve 2 secant squared x plus 3 tangent x equal to 4 with x in between 0 and 360 degree. If you take a look at the formula sheet, in the first few pages of this question paper, then you'll probably see this formula. Let me write it here. Secant square A equal to 1 plus tangent square A. This is a plus sign. Alright, it doesn't look so nice, so let me just get it nicer. Let me make it nicer. Alright, so this is plus. So if you have this equation, 2 secant squared x plus 3 tangent x equal to 4, then if you want to solve this, you need to make sure that there is only one type of trigonometric function here. So because we have secant and tangent, we either need to keep secant or keep tangent. But take a look at the formula above, this one. You can actually replace secant squared into a tangent squared terms. So let's go and replace secant squared theta with this 2 1 plus tangent squared theta. Alright, because this is equal to secant squared x. This is not theta, this is x, sorry. Let me repeat that. 1 plus tangent x, 1 plus tangent squared x is equal to secant squared x. So let's go and just replace that. Throw away the secant squared x and replace that with tangent squared x. So this complete that. Plus 3 tangent x equal to 4. So we have only tangent here in this equation. Let's go and open up that bracket. So this is 2 plus 2 tangent squared x plus 3 tangent x equal to 4. And let's move 4 over to the left. So it becomes minus 4. So it's left with 2 tangent squared x plus 3 tangent x. And then 2 minus 4 is minus 2 equal to 0. So let's go and divide. Now we cannot divide anything. We will keep it like that, and we factorize this equation. So over here is 2 tangent x, and this is tangent x, and we have minus 2 here. So we need to choose two numbers that produce minus 2. So it could be minus 2 and 1. Okay, minus 2 and 1. So I shall put, let's try minus 1 here and plus 2 here. So that minus 1 multiplied with plus 2 will result in minus 2. Let's check it out. 2 tangent x times 2, that becomes 4 tangent x. And then we have to minus 1 tangent x, which result in 3 tangent x. So this factorization is correct. Let's continue over this side. That means it is either 2 tangent x is equal to 1 or tangent x equal to minus 2, right? Because if either one of these is 0, either this one is 0 or this one is 0 or both. Okay, so either one of these are 0, so that means it's either 2 tangent x equal to 1 or tangent x equal to minus 2. So this becomes tangent x equal to 1/2, or this one remains tangent x equal to minus 2. So let's use well, before you use the calculators to find out the value, let's take a look at a Cartesian plane. Okay, tangent is positive in the first quadrant and the third quadrant, and that will support tangent x is to 1/2. Well, so you will probably get an angle like this. This could be our x, and then we have tangent x equal to minus 2, so that falls in either second quadrant or the fourth quadrant. So we have x in all the quadrants. So let's now use the calculator to find out the values, the possible values of x. So let's do an inverse tangent. So inverse tangent, where is it? Here, 1/2. That is equal to 26.57. Or, you see, that is the first quadrant. What about the third quadrant? So we want to find out this. That is equal to 180 plus 26.57. So that is equal to 206.57 degree, right? That is 180 plus 26.57. And then if tangent x is minus 2, then let's use the calculator again. Let's use inverse tangent again. Inverse tangent minus 2. Ooh. And then add 180, so 116.57. 116.57 degree, and the last possible value is in the fourth quadrant, right here. Well, you need to go one round, right? Because the angle is between 0 and 360. Okay, between 0 and 360. So that is, I'll calculate it again. Add another 180. So that is the fourth possible value, 296.57. So that's the four possible values of x. Let's move on to the next question. Number 16 is a vector question. Vector p is 12 minus 5 and vector q is k plus 1, 2. Find the modulus of p. So p, the vector p is equal to 12 I minus 5j. So it looks roughly like this. And this is 12i and then minus 5j here. Alright, so if we want to find modulus of vector p, then it's going to be this length. So we are going to use Pythagorean theorem. So modulus of p is going to be 12 square root of 12 squared plus minus 5 squared. Let's push down, and that is equal to 144 plus 25, which is square root of 169. Then this is equal to 13. So that's the answer. Question B. The value of k such that p plus q is parallel to the y-axis. Let's take a look at what is there. Okay, p is 12 minus 5 and q is k plus 1, 2. Let's go and write it down. P plus vector q is 12 minus 5 plus k plus 1, 2. So that is, it is equal to k plus 13, because that is 12 plus k plus 1, so that is k plus 13, and minus 3. Then if we are going to visualize how the vector p plus q looks like, so it's going to be something like this. Okay, something like that. This is p plus q, right? So moving this way, this is k plus 13, and then that way, and then this we have minus 3. But if this is to be parallel to y-axis, then k plus 13 must be 0. And as such, k is equal to minus 13. So that's the answer. Move on to the next question. If you have problem understanding the solution, then please replay the video. Rewind it and take a look at the solution again and again until you understand. In the meantime, let's go to question number 17. This is another vector problem. Diagram 17 shows a trapezium PQRS. Given PQ is 6A and PQ is 6A, and then PS is 4B, and then SR is 2/3 PQ. Express your following vectors in terms of A and B. What is the first one? The first one is PR. PR is this one. Okay, this is PR. PR is equal to PS plus SR. PR is equal to PS plus SR. Let's take a look at the diagram again. It's this one, right? PS is the red one, so that is equal to 2PS and then plus SR. But SR is 2/3 PQ. SR is 2/3 of PQ. But PQ is 6A. Let's put it here. SR is 2/3 of PQ, right? PQ. So that is basically 2/3 of 6A. So that is equal to, let's cut out 3 and 6. Come 2, so that is equal to 4A. So PS is 4B plus SR is 4A. So that is the answer. Alright. And BQR. QR is this one. Let's remove some of the unnecessary lines. So QR is this one going backward over here. So QR is basically QP plus PR. So QP plus PR. QR is equal to QP plus PR. QP is minus PQ and PR is 4A plus 4B and minus PQ. PQ is 6A, right? PQ is 6A. PQ is 6A, correct? So that is equal to minus 6a plus 4a plus 4b. So that is equal to minus 2a plus 4b. There you have it. That's the answer. Move on to number 18. Diagram 18 shows two sectors MON, POQ of two circles with common center O, where MOQ and PON are straight lines. Alright. So given ON is RCM. So this is RCM. OP is R minus 3 cm. R minus 3 cm. And perimeter is 42.9. That is the perimeter of the whole diagram. So find the value of R. So perimeter is this one. Alright. Complete perimeter. Complete perimeter is equal to 42.9 cm, and complete perimeter is equal to perimeter of OMN and plus perimeter of OPQ. OMN plus OPQ, that is equal to 42.9. So what is OMN? OMN is made up of two radius lines, which is R. So that's 2R, and then the curved line MN. So MN is equal to, remember this, S is equal to R theta. Theta is, in this case, 1.3 radian. So let's just use that to find arc length MN is equal to R theta, and theta is 1.3 radian. Sector MON is made up of two radius lines, then that is equal to 2R, and then an arc MN. So OMN, perimeter of OMN is 2 theta, 2R, sorry, not 2 theta, 2 theta, and 2R plus the length of the arc MN is equal to R theta, which is 1.3 R. And then OPQ is made up of two radius as well, but this radius is now R minus 3, so that is equal to 2R minus 3 plus the length of the arc PQ, which is R minus 3 multiplied with 1.3 radian. This is equal to 42.9. 3.3R plus 3.3 R minus 3 is equal to 42.9. Then that is equal to, let's factorize, that is 3.3 R plus R minus 3 equal to 42.9. So let's move 3.3 over to the other side. Move it over this side, becomes denominator. 3.3 over here. Move down. Okay, we don't have enough space down there. We continue with that on the right. So let's put it here. Then 42.9 over, let's use our calculator. 42.9 divided by 3.3, that is equal to 13. Then 2R minus 3 is equal to 13. So 2R is equal to 16. Because minus 3, if we move over to the other side, it becomes plus 3. Right? So it becomes 16. So Then we divide both sides with 2. Then left hand side is left with r. R is equal to 8 cm. So that is the value of r. We don't have to put the unit cm, because we just want to find. We are not trying to find the dimension, but we are trying to find the value of r. So let's just leave it as 8 there. So that is the answer. Alright, now our video is already about half an hour, so we are going to continue with number 19 in the next video. So see you again.